column space of this matrix and the basis of the null space of this matrix. So the column space is the span of each column of this, so all the vectors that make up this space, and we're going to find the basis of that, which is a set of linearly independent vectors that in a linear combination can span all of the free space just by themselves. Okay, so first I need to get this to reduced row echelon form. So I'm going to do row 1 minus row 3 and row 3 minus row 1. So I'll have 5 minus 4 is 1, 2 minus 2 is 0, 6 minus 5 is 1, 0, and I'll have 0, 0, negative 1, 0, negative 1, 0, and then I have 0, 2, 0, 1. And what I want to do is I want to get 1s in all of my pivot positions, which is the first non-zero term in each row, and I want to get this simplified so I have my pivot columns and my non-pivot columns, because the basis of a column space is the pivotal columns in the row reduced form, and then you plug those columns back into the original matrix, and those are the vectors that make up the basis. So I'm going to keep row reducing, row 2 plus row 1 is 2, and row 3. Row 1, 3. I'll have 1, 0, 1, 0, 0, 1, 0, 0. I have zeros here. 0, 2, 0, 1. And I'll do row 3, swap with row 4. So if you have a row reduced form, you want all the zeros on the bottom. So 0. Now I'm going to do row 3 minus 2 times row 2, new row 3, so I have 1, 0, 1, 0, 0, 1, 0, 0, 0, 2, and then I have 0 here, and I have 0 here, 1, 0, 0. So my pivot columns are, here's my first pivot, second pivot, my last pivot. So these 3 columns are my pivot columns. So then the basis of the column space is this first column. So 5, 0, 0. Second column, and the fourth column. So now I have to find the basis of the null space. And the null space is whatever vector you can multiply by a to get the 0 vector. So I'm going to use this, already in row reduced echelon forms, augmented with the 0. I have x1 plus x3 equals 0, x2 equals 0, and x4 equals 0. And I want to write the pivot positions in terms of the free variables, which would be x3 in this case. So x1 equals negative x3, and these other 2 pivots equal 0. So my final equation would be x3, and in this case the free variable can be any real number, so I'm just going to use this vector, which can be multiplied by any number. I have negative 1, 0, so x2 is 0, 1, x3 times 1 is x3, and 0, because x4 is 0. And that's the basis of your null space.